Hey, welcome to the shop. Just kidding. We're in my house. Basically was setting up to film all this and it began to rain, so had to take it all back down, bring it into the house, and thought, oh, I'll just do a shot in my house. So here we are in front of my fireplace. Pretty much the best looking place of the house, I think, anyway. So today we are going over differentials, and that is again in drivelines 2. So we are dealing with differentials. We're dealing with the competency of being able to measure the differentials and all the different parts inside, dealing with spider gears, ring gear, the pinion, all that, and how they are in relation to each other, and contact points, end play, run out, all that kind of stuff. So we're going to go in a little step by step. I'm going to keep it quite as general as I can so that you can apply this information to all differentials. But the differential that I'll show in my video and my demonstrations is pretty much for more of a pickup truck. You're looking at probably, I think this is for like a 90s S10. So not everything will apply here. You will have possibly different setups, such as cross spiders, things like that, instead of just the spider gears that we have here. You'll also run into the difference between a semi-floating axle and a full floating axle, and I'll maybe touch on that a little bit as well. So the first thing you want to do is you're going to go ahead and pull off the back cover of the differential, and before you start ripping everything apart, you want to start out with a series of measurements, because you want to know where the problem might lie in your differential, because of course you're taking it apart to find the problem. So the first thing you're going to do is you're going to measure the ring gear end play. So you want to go ahead and take your dial indicator, you want to set it up like shown, and you want to measure the end play. Now the end play is basically checking on the shims and the bearings and how tight it is against the pinion, the pinion gear. So you're pushing it back and forth, you're looking for a reading, you want 0. You want 0 to show up. Now the spec can be different depending on the type of differential that you're using, that you're checking it against, but you want to consult your manual for all your specs. First thing, make sure you have your manual, consult it for all the specs, torque specs, resistance, all that kind of stuff, the run out and the end play. So again, checking the end play, it should read as 0. Now after you've checked the end play, the next thing you want to go to is the ring gear run out. So you'll set up the gauges shown, and you'll basically, spinning the pinion, you will run the ring gear around, and that's basically checking for ovality of the ring gear. You have to take note that like on this ring gear, there was information stamped on the ring gear, so you will get variation in your reading when it runs over those bumps. But without taking that into account and checking it again, you shouldn't see too much run out. You shouldn't see hardly any run out whatsoever. But again, check that against your specs to see what the allowable run out is. Now the next thing you want to check is backlash. Now this is tooth backlash on the ring gear. So basically when the ring gear is hitting against the pinion gear, you want to see how much play there is in between that pinion gear. So those teeth, how they're clashing and going back and forth. So you want to hold the pinion gear steady, and you want to give just a little back and forth on the ring gear to see the needle make its play. And again, checking that against what it should be so that you can see if you have any problems as far as shimming of your pinion or shimming of your ring gear or the assembly. So after you've checked those, you're next going to get this paste right here, or a similar paste, and you're going to apply it to your ring gear. You're going to run it around, and this will allow you to check the tooth contact pattern. So you're going to see how that pinion gear goes up against the tooth and where it leaves its mark. Now you're going to have to put some pressure on your ring gear to kind of allow it to make that impression. That way you can get a clearer reading. But depending on how your tooth contact pattern shows, will show you what kind of wear you may be having. You know, are you barely contacting the teeth, or is the contact point off the edge of the teeth? Does it ride perfectly in the center where you should have kind of a rounded rectangle, rectangle pattern where it's just perfectly applying on the full face of the tooth? Because if you're not getting that full contact, you could have slippage, definitely future problems. So you're going to check the tooth contact pattern. Next, you want to go ahead and you want to disassemble, or go into the disassembly. Once you've pulled out the ring gear and pretty much pulled all the spider gear, the side gears, pulled all those out, you want to pretty much run an inspection on all those gears, looking for any chips, rusting, anything like that. So you're inspecting all the gears as you pull out that assembly. Then you want to check the pinion. So you're going to want to pull the pinion out, and you want to look at the pinion shims. So the pinion shims, I'm going to show right here. The pinion shims are between the bearing and the pinion gear, and you want to see how many shims there are located in that. Now, the bearing is usually pressed on, but here we had the bearing removed and it was a little honed out, so we can slip it on and off in order to do the demonstration. But the bearings are usually pressed on for that first bearing. So you want to see how many shims there are, and basically that'll help you with getting your shim depth. Now there is a tool out there that will allow you to calculate the shim, or the pinion bearing depth. We didn't have that. I wasn't able to demonstrate that, but this will go hand in hand with your pinion shims and the depth. So after your parts inspection, after you've checked out the shims on your pinion, the next thing you want to go into is pretty much your pinion preload. So you want to take basically an inch-pound torque wrench, or this gauge that we have here, and you want to reinstall with your pinion shims, and you're basically checking the rotation of the pinion. And with that rotation, normally, depending on what it is, will give you, your manual will tell you what it should be. So I think for this one, we were getting, our manual said 10 to 20 inch-pounds for the preload. So if you're falling in, in say 10 inch-pounds, as you're assembling everything, you're going to start to see just the slightest increase. It's not a whole lot, maybe an inch-pound or less. So as all the assembly comes together. So you're checking the pinion preload. Now, after the pinion preload, you're going to check the ring gear load. So you're going to have to pretty much, how do I put this? You're going to start with the ring gear, put it in, and you're going to be checking the preload. You're also going to be checking the ring gear shims, because there are shim packs on either side of the ring gear, on the either side of the ring gear bearings. So kind of sitting in with the journal, there is a shim load packs. Shim packs. And so what you'll be doing is you want to shove all the shims into one side, kind of pulling it away from the pinion, And this is the process. You're going to be moving shims from one side to the other, but not just moving shims one side to the other. You also have to put on the saddle for the journals over top of, and you basically tighten it down, and you're checking the end plate to get that tooth or those teeth meshed up with the pinion again properly so that it reads 0 on the end plate. So once you go through all that and you get all that together, then you can start working on the rolling torque of the spider assembly. So once you've installed the spiders and everything into the ring gear assembly, you can then run your rolling torque, where you will have to rotate it around so you can get to the pinion, again using your inch-pound torque wrench or your meter, and then you're going to have to hold on one of your axles and to allow the pinion to spin, because the pinion, or to basically allow the spider to spin, because the ring gear tends to want to spin and go around the spiders without causing the spiders to spin. So you have to hold one down to cause the spiders to spin, basically allowing the gears to work. And then as you spin the pinion, that will all generate and give you your torque. So once you've checked that, your shims are in place, everything is tightened down, the last thing you want to do, you want to kind of go back over it and you want to check the end plate again. You want to check any tooth backlash, and then you want to go into your final check, which is checking the tooth pattern one last time. And once you've done that, you've pretty much completed a full inspection on your differential. So remember the orders when you start. So for those of you at JTech who are doing the competency, depending on the teacher that you have, you want to start with just pulling off the cover, checking the end play, checking the runout, checking the backlash, tooth contact pattern. Then you can begin your disassembly of the ring gear and the ring gear carrier. Pull all that out. Run your inspection on that. Check your pinion shims by pulling your pinion out and checking the shims. Then you go into reinstalling your pinion, checking the pinion preload, checking your ring gear load, and the ring gear shims. So shimming it up, doing that, which I said is a process. It is a long process. And then going into your rolling torque of the spider assembly, making sure all that is correct, having put your spiders together correctly, and then you're going back into checking your backlash again, your end play again, and then your tooth pattern one last time, and all that should pretty much finalize your inspection on a differential. So thanks for joining me and bearing with me through this rainstorm. See you in the next video.